Hey guys, in this video lecture we will be solving your mathematics class 10 exercise 1.2. So express each number as product of its prime factors, and the first one is 140. Okay, so we will solve it out. 140, we have to express it as product of its prime factors, dividing it with the first and the smallest prime factor 2. 2 7s are 14 and 0. 2 3s are 6, 2 5s are 10. Sorry, it won't be any more divisible by 2. 5 7s are 35 and 7 1s are 7. So you would get here the result as, you can write it here as 140 will be equals to 2 into 2 into 5 into 7. That will give you the result as 2 square into 5 into 7. Okay. Now coming to the next one, that is 156. Starting with 2 again. Since it is an even number, 156, it will be divisible by 2. 2 7s are 14. 2 8s are 2. 3s are 6. 2 9s are 18. 3 1s are 3. 3 3s are 9. And 13 1s are 13. So you can write it here as 156 is equals to 2 into 2 into 3 into 13. That will be equivalent to 2 square into 3 into 13. Now coming to the third one, 3825. Okay, factorizing it, 2835. Now since this is an odd number, this won't be divisible by 2. So starting with 3, 3 1s are 3, 3 2s are 6, 3 7s are 21, and 3 5s are 15. Next, again dividing it by 3, we get here 4 2 5. Again, now this won't be divisible by 3 anymore, so dividing it by the next prime factor, that is 5, we'll get here 85. Now again dividing it with 5, we will get here 17, and ultimately we will get here 1. So 3825 can be expressed as 3 into 3 into 5 into 5 into 17. That will be equals to 3 square into 5 square into 17. Now the next question is 5005. So factorizing it, okay, so this won't be divisible by 5. This won't be divisible by 2 and 3. So dividing it with 5, 5 1s are 5, 0 0, 5 1s are 5. Now this won't be divisible by 2, 3 and 5 again. So dividing it by 7, 7 1s are 7, 7 4s are 28, and 7 3s are 21. Now dividing it by 11, you will get here 13, 13 1s are 13. So you can write it here as 5005 will be equal to 5 into 7 into 11 into 13. Okay. Now the next question is 7429. Okay, so 7, 4, 2, 9. This is an odd number, so it won't be divisible by 2. So dividing it by 17, you would get here, dividing 7429 by 17, you would get here 437. Since 17 is also a prime factor and this number won't be divisible by 2, 3, 5 or any other prime factor smaller than 17, so we divided it by 17 at first. Now dividing it with 19, we got here 23, and 23 ones are 23. So you can write it here as 7429 will be equal to 17 into 19 into 23. So our next question is, find the LCM and HCF of the following pair of integers and verify that LCM into HCF is equals to product of two numbers. So the first number is 26 into 91. Okay. So we will find out the prime factors first. The prime factors of 26, dividing it with 2, here we got 13, and 13 itself is a prime number, so here we got 26 is equals to 2 into 13. And for 91 also we will perform the same prime factorization. 91, it won't be divisible by 2, 3 and 5, so we will divide it by 7 at first. 13 ja 91 and 13 ones are 13. So you can write here as 91 will be equals to 7 into 13. Okay. So in these two numbers, in these two factors or prime factors, what is common? So the HCF will be equals to highest common factor is 13, and here we'll have to find out the LCM as well. The LCM will be equals to 2 into 7, because these two are not common, and since 13 is common in both of them, so we will write a single 13 for both of them. So we will get the product as 182. Now we also have to verify that LCM into HCF is equals to product of two numbers. We need to verify that thing, so we will verify that out. Okay, so here HCF into LCM will be equals to HCF we got here as 13 and LCM we got here as 182. That will give you the result as 2366. And in the RHS we have product of numbers, that means the numbers are 26, given numbers are 26 and 91. So 26 into 91 will also give you the product as 2366. Therefore you can write here as LCM into HCF is equals to product of two numbers. That is proved. Right? Now moving on to the next question. So the next question is 510 and 92. So the prime factorization of 510, it is an even number, so definitely it will be divisible by 2. 2 2s are 4. 250 we will get here. Now dividing it by 3 we get here 85, and dividing by 5 we get here 17, and finally you can write it here as like this. So you can express 510 as 2 into 3 into 5 into 17. Okay, the next number over here is 92. Okay, so we will do the same prime factorization method for 92 as well. 2 4s are 8, 2 6s are 12, 2 2s are 4, and 2 3s are 6. 23 is a prime number, so it won't be divisible anymore. So you can express 92 as 2 into 2 into 23. So the HCF of 510 and 92 will be equals to, what is the common factor? 2. And is there any other common factor between them? No. So the HCF will be equals to 2. Now LCM of 510 and 92 will be equals to, for these two we will write a single 2 into, there is one more 2 which is not common, 23 is also not common, then we can write here 3 also which is not common, into 5 into 17, into 5 into 17, and the LCM you get as 23460. Okay, now we also have to verify that LCM into HCF is equals to product of two numbers. So first we will find out that LCM into HCF, that is 23460 into 2, that will give you the result as 46920, and product of two numbers, that is equals to 510 into 92 will also be equals to 46920, and hence since these two are equal, so LCM into HCF is equals to product of two numbers, and this is again proved. Okay, now moving on to the next question. So our next question is 336 and 54. The prime factorization of 336 will be, as this is an even number, dividing it by 2 we will get here 168, again dividing by 2 we'll get here 84, again dividing by 2 we will get here 42, again dividing by 2 you will get 21, and this won't be divisible by 2 anymore, so you get here 7. Okay, now the next number is 54. So prime factorization of 54 also will have to perform. This is also an even number, so dividing it by 2, 2 2s are 4, 2 7s are 14, this won't be divisible by 2 anymore, so dividing it by 3, 3 9s are 27, 3 3s are 9. So here you can write, that 336 is equals to 2 into 2 into 2 into 2 into 3, and 54 is equals to 2 into 3 into 3 into 3. So now we'll have to find the HCF and LCM. HCF of 336 and 54. So what are the common factors between them? These two 2 can be taken out, and these two 3 can be taken out. Rest of the things are not common. So 2 into 3, that will give you 6. Now similarly, LCM of 336, sorry, here I am putting a multiplication sign by mistake. It should be comma, and 54 would be 2 and 3. These 3 are taken common. These 2 and 3 are taken common, and rest all other stuff we have to write it. These 3 2's, it means 2 into 2 into 2 into these 2 3 into 3. That will give you the result as, okay, and here there was one more 7 as well. I missed it out. 7. So one more 7 should also be written over here. So you will get the result as 3024. Now for verification, Hcf into LCM, that is 6 into 3024, will give you the result as 18144, and the product of two numbers, that is 336 into 54, will again give you the result as 18144. So these two are also equal, and so product of the two numbers is equals to Hcf into LCM. This is also proved. Now moving on to the next question. Find the LCM and HCF of the following integers by applying the prime factorization method. So by applying prime factorization method, you have to find the LCM as well as the HCF of the numbers. And in this case, you have been given 3 numbers. Okay. So the first question is 12, 15 and 21. So let's begin with the first one. First we will find the prime factorization. First we will find the prime factorization of 12. Okay. So first dividing it by 2, 2 6 are 12, again 2 3s are 6. Okay, the next number is 15. So dividing it by 15, it won't be divisible by 2, right? So the next prime factor, that is 3, 3 5s are 15. The next number is 21. So by prime factorization method, it won't be divisible by 2 again, so it will be divisible by 3, 3 7s are 21. Okay. So in this case, you can write it as 12 is equals to 2 into 2 into 3. And also you can write that 15 is equals to 3 into 5. And it can also be written that 21 is equals to 3 into 7. Okay. So now we need to find the HCF as well as the LCM. So what are the common numbers between them? 2. Is 2 common? No, 2 is not present in the factors of 15 and 17. Can 3 be taken as common? Yes, of course, because 3 is common in all the 3 numbers. See. So, and 3 is the highest common factor because it is the only common factor that we can take as common. So it can be written as HCF of 12, 15 and 21 is equals to 3. Now we know that LCM into HCF is equals to product of two numbers. But in this case we have been given 3 numbers, right? You have been given 3 numbers, so this rule won't be applicable in this case. So we have to move to some other formula, or by other method we have to find out the LCM. Now by finding out the LCM, it's also very easy. As we have the prime factors, we can also find out the LCM, and that can be written as LCM is equals to, how you can write, see, the things that you can take as common, that is 3, and all those numbers that you can't take common can be written here once again. Okay, that can't be taken as common are 2 into 2, that is 2 into 2. The next one is 5 and the next one is 7. So this will give you the result as 420. So the LCM is equals to 420 and the HCF is 3. Now moving on to the next question, that is 17, 23 and 29. Same way we will proceed. We will first find out the prime factors of 17. Okay, so 17 itself is a prime factor, okay, prime number, so its factor will be 17 itself. The next number is 23. The factors of 23 is again 23 itself, because 23 is again a prime number. And the next number is 29. So 29, as 29 is also a prime number, so its factors will also be 29 only. As these 3 numbers are prime numbers, so it cannot be divisible by any other number. That's why the factors will be the number itself and 1. Okay, so now 17 can be written as, the factors of 17 can be written as 1 into 17. The factors of 23 can be written as 1 into 23, and the factors of 29 can be written as 1 into 29. Okay, so the common factors, that is highest common factor, that is HCF, will be equals to, see, 1, and LCM will be equals to 1 into all those things which are not in common, 17 into 23 into 29 into 23 into 29, that will give you the result as 11339. This is the answer. Now the next question is 8, 9 and 25. So the prime factors of 8, first we will need to find 2 4s are 8, 2 2s are 4, and 2 1s are 2. Okay, now for 9 also we will do the same way. For 9, it won't be divisible by 2 as 9 is an odd number. So it won't be divisible by 2 as I said. It will be divisible by the next prime number, that is 3. 3 3s are 9 and 3 1s are 3. Now coming to the third number, that is 25. So it will be divisible by 5. 5 5s are 25, and then 5 1s are 5. Okay, now you can write 8 is equals to 2 into 2 into 2. You can write 9 is equals to 3 into 3. And you can write 25 is equals to 5 into 5. And into 1 also you can write it over here. Now you need to find the HCF and LCM. So HCF will be equals to the common factors. First we will find out the common factors. Is 2 common? No, 2 is not present in the factors of 9 and 25. Is 3 common? No, 3 is again not present in the factor of 8 and 25. Is 5 common? No, it is also not common. So the common factor is only 9. So HCF of 3 numbers, sorry, not 9, the HCF of 3 numbers are 1. Now we also need to find the LCM of the numbers. So it can be written as Lcm is equals to, what are the common factor? First we will write that one. Next, what are the uncommon numbers? These 3, 2, that means 2 into 2 into 2 can be written. This 2, 3, that means 3 into 3. Next, this 2, 5 can also be written, that is 5 into 5. And you will get the result as 1800. Okay, moving on to the next question. So in this question we have been given that the HCF of these two numbers, that is 306 and 657, is 9. That means we have been given that HCF is equals to 9 and the numbers are 306 and 657. We have to find out the LCM. Okay, so here there are only two numbers, 306 and 657. So in case of two numbers, you can easily apply that formula, that HCF into LCM is equals to product of the numbers, and the numbers are 306, product of two numbers, 306 and 657. So here the HCF is 9 into LCM is equals to 306 into 657. Now taking this 9 down, you can write, we'll take 9 to the RHS, 306 into 657 by 9, that will give you the result as 22338, and this will be the answer. Here in the next question you have been given that check whether 6 to the power n can end with digit 0 for any natural number n. Okay, we have to find that this 6 to the power n should end with some digit 0. We need to find that. So for ending any number with digit 0 means it should be divisible by the number 10. If you want any number to end with digit 0, like the number can be 100 or the number can be 600, 6000, or it can be 60, or it can be anything like 36000. It should, if you want it to end with digit zeros, then it should be divisible by 10. Now the factors of 10 are, if you find the factors of 10, then you will get to know that the factors of 10 are 2 and 5. So this 6 to the power n should be divisible by these two factors, means this 6 to the power n should be divisible by 2 and should also be divisible by 5. Now the factors of 6 are, what are the factors of 6? The factors of 6 are 2 and 3. 3 into 2 is equal to 6. So the factors of 6 are 2 and 3. So this is not possible, because you can write now, therefore it can be written as 6 to the power n is equals to 2 into 3 to the power n. So here it's 3, but we needed it to be 5. for the number to end with digit 0, we want the factors should be 2 and 5, but here the factors are 2 and 3. So it will not be divisible by 5, means 6 to the power n. If it's ending with digit 0, then it won't be divisible by 5. So it's not true. So the answer will be no. That is, no, 6 to the power n cannot end with the digit 0 for any natural number n. Moving on to the next question. Now in our next question we have been given, explain why 7 into 11 into 13 plus 13 and one more expression, that is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5 are composite numbers. We have to find it out. Okay, so considering the first expression, 7 into 11 into 11 into 13 plus 13, we have to prove that this is a composite number. Okay, so before moving to the proof part, we will first I'll explain that what are composite numbers. I have already explained that in the previous lectures, but still, composite numbers are those numbers which have more factors, which has 2 or more than 2 factors other than 1. Okay, so we will solve this expression. So for solving this expression, that from this term and this term, you can take 13 as common. Taking 13 as common, you will get there 7 into 11, and as this 13 is taken as common, so inside you will get 1 within bracket. Now you can write here 13 into 7 into 11, that will be 77 plus 1. Again you can write here, that is 13 into 78. Now this 78 can again be factorized and written as 13 into 6. This 78 can be factorized like this way, and you can write it like that. 2, you can factorize it easily, right? 2 3s are 6 and 2 9s are 18, 3 1s are 3, 3 3s are 9. So this 13 and 3 into 2 will be 6, so that's why 6 and 13 is written. Okay, so here you got that the factors of this particular number, the factors of this expression are 13 into 13 into 6. So we have other factors, we have more factors, like we have got 2 factors, that is 13 and 6, except one we have got 2 more factors, and that is what composite number states, that this is what the composite numbers actually are. So this expression is definitely a composite number expression. Okay, now moving on to the next expression, that is this one. I'll write that expression as well, and the expression is 7 into 6 into 5 into 4 into 3 into 2 into 1 plus 5. This is the expression that we have got. So from this value and this one, we can take 5 as common. See, we can take 5 as common. So taking out 5 as common, you'll get here inside 7 into 6 into 4 into, this was 3 into 2 into 1, and this one can be taken as 5 is taken common, so it will remain as 1. So this will give you 5 into, if you multiply all these, you will get 1 008 plus 1. So that will be equals to 5 into 1, 009, and this number, these two numbers are already prime factors and it cannot be factorized any more. So again here we have got two factors other than 1. Two factors of what? Two factors for this expression, and these two factors are not 1. These two factors are other than 1, and the composite number statement expresses that if you have two or more than two factors. So of course we have got here two factors, so this is also a composite number expression. Moving on to the next question. So for the next question you have been given that there is a circular path. There is a circular path around a sports field. Sonia takes 18 minutes to drive one round of the field, while Ravi takes 12 minutes for the same. Ravi took 12 minutes but Sonia took 18 minutes. Suppose they both start at the same point. Both of them started at the same point and they go in the same direction. After how many minutes they will meet again at the starting point? After how many minutes they will meet again at the starting point? So here you can find that Sonia took 18 minutes while Ravi took 12 minutes. So of course Ravi took less amount of time as compared to Sonia. So we will here find out the LCM of 18 and 12. If you find the LCM of 18 and 12, then you will get to know that after how much time will they meet again at the starting point. Okay, so let's do that. We'll find out the LCM by finding the prime factors. So 2 9s are 18, 3 3s are 9. Performing the same way for 12, 2 6 are 12, 2 3s are 6. Now here again you can write 18 is equals to 2 into 3 into 3, and 12 is equals to 2 into 2 into 3. Now I have to find the LCM that will be equals to, first we will take out the common terms. These 2 and these 3 are common. So we will write a single 2 and single 3 for these 1, and this 3 will be placed here and this 2 will be placed here. So you will get the answer as 36. So after 36 minutes they will meet again at the starting point. Thank you.